but thank you so much for attending this webinar. This is on the Perfect DFMEA and the launch this week of the Perfect DFMEA handbook, which is in the series of handbooks we've put out this year. This is the fourth one. And the idea is that these are the four most fundamental tools in the design for reliability process: the perfect DFMEA, the perfect accelerated life test, the perfect reliability growth test, and the perfect halt test. And together, you'll be able to have a significant influence on the design process to make sure you design the most robust product first. If you like Instagram, follow me on Instagram. I do 60-second atom bombs twice a week where I just kind of drop some knowledge on whatever is happening to me at that moment with regards to reliability or, a thought that I got inspired by. And, I think you'll enjoy it. And I post a lot of content on LinkedIn. And you, of course, can always join my mailing list by going to adambarrett.com and join there. And you'll get, the newsletter in your inbox and a bunch of other good content. So let's jump right into it. So let's start with the definition. As everybody knows, I love language, and I feel that language is really a key part to reliability being effective. The definition of FMEA, the formal definition, is that an FMEA is a systematic method of identifying and preventing product and process problems before they occur. So FMEA stands for Failure Modes Effects Analysis. And what we're looking to do is to look at the future. It's hypothetical. What could happen? We are looking to be proactive. All these words are looking to the future to have us be able to take action to mitigate what could happen. So the opposite is reactive, which is what we're looking to eliminate with a DFMEA. There is time investment in a DFMEA, but the return on investment is amazing. It's really a time saver when done correctly. And when I say done correctly, that's a big deal because a DFMEA is a powerful tool. And when done incorrect, can be a tremendous drain on morale, on time consumption. I'm sure many of you have experienced very painful and traumatic DFMEAs. And it hurts in two ways. One, it slows down the project without adding much value. And then two, when you want to do a DFMEA again later for another program, it's easy for leadership to point to how ineffective they are. But if it's done correctly, it's not a huge consumer of time. And the time invested in it is actually a huge savings because you are going to be eliminating the time you'd spend reactively dealing with a lot of these same issues later. So the proactive versus reactive concept is really fundamental to understanding the value. So there's many different types of failure modes effects analysis. We have the design FMEA, which is typically for hardware, electromechanical systems. You have a process FMEA, PFMEA, which is associated to manufacturing, but can be applied to other processes or operations. You have maintenance FMEAs. This is focusing on getting the strategy right for the maintenance program for a product. And we have software FMEAs. But design FMEA is what we're going to focus on this webinar and what the book is about. So the process is straightforward, where we start by selecting our systems. We scope our boundaries, and we then begin to explore and go through that hypothetical analysis of the system based on the expertise in the room. And we'll talk about what in the room means. There are the right ways to have this be conducted, and there's the right people to have be present. But we go through a process of identifying failures, assigning scores based on severity, likelihood of occurrence and detection, calculating a risk priority number, sorting by that number to make sure we're going after the critical few issues and not the trivial many. And this concept is a big deal because part of the value is that we have very limited resource. And of course, we can't go after every risk there is with our product. So what we want to do is make sure we're always using our time going after the most critical issues. And so that's why having a system where you're actually taking it and qualitatively changing it to a scoring to where you have a risk priority number that you can sort in descending order, you make sure you're always going after the critical few elements at all times. And as you're solving them, other ones are coming to the top, but you've always used your time efficiently. So we're looking to make sure it's driving action. We have to be careful because so many DFMEAs fall in the trap of simply being executed for the sake of being executed. This can be driven by a external request. It can be driven by needing to check a box in some requirements process, a process with requirements. But we have to make sure it's driving action. If it's not driving action, it's not yielding real value because of that core objective, which is to help us make sure we use our resources in the most efficient way possible. So the history of DFMEA, it started with the military, and there were specific standards created. Then NASA picked it up, and again, they made their own versions of it. Aerospace and air manufacturer industries created their own standards, and then ultimately after that, the automotive industry created their own standards. And they each made their own flavor of it that was optimized for their design process and how they wanted to address risk. So it really is okay as you get experience with them to adjust it and to make sure it's serving its purposes of helping direct you towards using risk analysis to make sure you're using your resource as efficiently as possible. So since we're not doing it to check a box in a standard and we're doing it for that reason, you really are free to modify it in any way you feel better serves that purpose. So the method comes from blending together a lot of other tools that are used in different industries in different ways for different objectives. But we're really looking to bring them together so that they holistically can serve this purpose of helping us drive by risk. One is Kaizen, and Kaizen is about being at Kaizen is about doing this constant continuous process of identifying issues and implementing solutions. And it's really a mindset. And you can see here looking at the DFMEA process, where once we get that risk priority number to where we want to direct our attention and begin to solve that solution, how we then will stay in that loop of constantly evaluating, directing action, finding solutions, and then coming back again. So the Kaizen principle and mindset is really key to the DFMEA being effective and really serving the program well. The 5 why root cause method. This is something you may be familiar with, and it's used in lots of different product development tools. I find it to be such a tremendously effective tool because it's so intuitive. It's so intuitive that if you have children or if you recall when you were a kid, you use this method to understand what's going on around you. A child will ask you, why is such and such a thing or happening? And you'll answer, and then they'll say, well, why is that? And you'll answer, and they'll say, well, why is that? And it's a very intuitive way to get to the root cause or the core principle of something. So it really can be amazingly effective from going from a problem statement to a root cause you can take action on. So with FMEAs, DFMEAs, we're doing this. We are going from something that occurred, trying to get to the ultimate cause and the effect. And by bringing that resolution to it, we're able to score categories that are important to us, most commonly severity, likelihood of occurrence, and detection, and now turn it into something that we can give a total risk priority number to. Fault tree analysis is another tool and mindset that becomes a part of it. With fault tree analysis, we're looking to create a logical path for how a failure can happen. And this can be displayed graphically and very commonly is using very common and/or gate type of symbols. And feel free to have this be in the process. Now you'll see I encourage to have this type of analysis not done in the session, but it can be an action item that comes from the session done outside with the results brought back in. So what does a DFMEA look like? So this is a very typical DFMEA worksheet, and you'll see in the book that there are downloadable worksheets included to get you started. They are in Excel, and a lot of the other specific aspects to help you set it up are involved there in there as well. But you can see here that the DFMA can be done top down or left to right. I always prefer to go left to right. Left to right is following along that 5 why root cause analysis method. And so what you're doing is you're starting off with system functions. I don't like to start with bill of materials, which some of the standards suggest you do. I find that this takes us too far away from really going through the system and letting the functionality drive where we want to bring our attention to. And so I like to list out the major functions and subsystems associated to the functions. We can go down then to components, or, again, you can break it down to a subfunction and then begin to list out the failure modes. And from there, we'll list out the effect of the failure. You might use some of the other tools to do that, to go from that. And we then begin to do scoring. And the scoring here, the first score is severity. And I will go a little bit into how you create that table and that scoring method. Then we talk about the cause and we give a score to the likelihood of occurrence of that cause. Talk about prevention and detectability, give a score to detectability, and ultimately calculate the RPN number. So you can see here in these examples for a line item, we had 4, 3, and 5, which ended up with an RPN number of 60. So when you have that final RPN number for all your line items, like I said, you're able to sort in descending order and see where your attention should go to first. Now, I've talked about how, a DFME is being done right when it's driving action. And so here's an example where there was a line item where, in this case, it was a downstream pressure sensor. The function was input. The failure mode, it didn't indicate the correct pressure. The effects were over and under infusion in the system, so the control system was getting the wrong inputs. And what you ended up with was binding. So we had a severity of 5, which in this case for our scale was the highest severity. And the likelihood of occurrence was a 4, and the detectability was very poor. So we ended up with a high RPN number. So we wanted to understand more about the sensor. So then the idea was, well, how about we use Hall testing to do a very quick investigation, understanding how they can fail. So right away, there was an action that could be done, when this line item was identified and seemed to be very likely to be a high number compared to other ones we've done. And so within the DFMEA process, this test could be done, in between sessions, and the results brought back even within the higher level process not having been completed yet. So with the accelerometers, we're able to find out, able to monitor the binding and what could happen with the sensors, which allowed us to come up with a solution that changed the scoring. And in doing so, changed the rankings with right away in the process, and we're able to then evaluate it again. So a closed loop mindset, that Kaizen idea. So I just quickly want to bring up the R3 process, which is an approach I feel is really great for ensuring design for reliability can have a big impact on how we make robust products the first time. And the reason being is that DFMEA is one of the core elements in being able to implement R3. So the first R is the ratio factors, and ratio factors are the different specifications we have for our product and program that we have decided need to have specific targets for the product to grab most market share and be successful. So 4 very common ones are cost, features, time to market, and reliability, and these compete with each other. Obviously, time to market can be a competitor for reliability because reliability tests take time, redesign takes time, assessment and analysis take time. So those two will be competing. So it's really important to know their relationship to each other with regard to how we want to have this product be successful. So here's an example. Let's take a rover, right? So the NASA rover, which we're all familiar with. It's a relatively simple robot in functionality. It has wheels that turn. It has, robotic arm that moves. It has a camera. It has the ability to transmit and receive information. So none of those functions are particularly new or cutting edge. But in that program, what made it really special was the reliability had to be astounding. The reliability, there's no opportunity for service. There is a $1 billion launch program built around it. And if the robot was to go out there and some simple functionality fails, that could be the value of the entire mission. So let's compare that to something that's similar but very different. A kid's toy rover. We've seen the Mars rover as a toy, a fully functional toy, all the same functionality. It rolls, it moves, a robotic arm moves, has the camera, has the ability to transmit and receive data, but obviously a very different program. And in this case, time to market and cost point are extremely critical for them to be successful. And reliability can be low. With time to market's critical because if you are aiming for a certain season, a holiday season, you need to be on the shelf at the same, far in advance of the holidays so that it's very much more likely it gets purchased. And with regard to if it gets purchased, the cost point has to be competitive with other toys. And they may not be robots. They could be other things like board games or video games or all kinds of things. And so those 2 points are critical for it to be successful. Reliability, there's actually a good chance that a large percentage of the children who receive it lose interest after a few months, right? It ends up in the back of the closet. They received 1 million new toys, for the holidays. So reliability may not be as critical a factor, and you can have some higher risks in there with regards to whether or not it functions as well a year, 2 year, 3 years later as it did when it was brand new. And you're not willing to compromise doing reliability initiatives that could potentially make you miss your time to market. So these are the ratio factors and how they are critical to identify and have navigate your product development process, and that navigates what's key with regard to how it connects to design for reliability. The second one is robust ready. And this is all about early in the product development process with our technology. We don't want to spend a lot of time using reliability measurement tools. It's too early. Our goal is to build strength. We need our technology to we need to find the failures in our technology, root cause them, and come up with solutions as quickly as possible. If we spend a lot of time trying to measure the reliability of our product that early in the program, we are losing this very small window we have where we can make easy improvements. And we're losing the opportunity to have resource and use test stands for these finding failures rather than demonstrating reliability. And this can be really tricky because leadership, a lot of times, once a prototype works, their next question is, how reliable is it? And they will push very hard for measurement, unknowingly that they are having you miss that window where you can make a lot of changes quickly. So DFMEA here this may not be the time to put a lot of effort into a DFMEA where you're looking to identify risk to see where you need to improve. There might be versions of it that can help, but really robust ready is about quickly doing tests that expose failures. Where DFMEA can have a big impact is in the risk guidance, the third R. Risk guidance is about making sure we're using risk assessments to direct where our actions are as we progress through the program. Because later in the program, after we've done our initial robust, surge of robust improvement to increase strength, we're going to then need to be very surgical with regard to where we put our effort. And this is where a DFMEA can have a tremendous impact in ensuring it guides us to stay on the path to get our most reliable product. So there are 5 tenets for the perfect DFMEA. The first is preparation, which has to do with what the people who are driving the DFMEA do before the team starts their first session. The second is having the right team. There's a couple factors that you should keep in mind as you're creating the team, and we'll go into those in a bit. Active in the design process. If the DFMEA is not part of the design process where it is driving actions that are being carried out and things that are happening in the design program are not making it back to the DFMEA, the value has been tremendously reduced. Administrator roles. You can't just have the technical team be the only participants in the DFMEA. It's really important to make sure that it is being managed and being very intentionally directed by some higher level roles. Time management. This is a huge one. This is where you can easily have a DFMEA that's really powerful and have it go off the rails. If you are not careful with how you're using the team's time in the DFMEA process, it is very easy to have them effectively become disengaged because so much time is being wasted and their time is being wasted. So the first one, preparation. Uh, Preparation, is what we do before we get engaged in our activity. And we have to keep the intent of our activity in mind. What are we looking to accomplish? What do we need to do to make sure as we execute, we are ready? So one of the things we should do in preparation is create our risk tables. You saw how we use the risk numbers in the DFMEA process. So we don't want to create those tables as we're doing the DFMEA. We want them to be created in advance. And you can do a scoring of 1 to 10. A lot of times I just do a scoring of 1 to 5. And if it turns out we need more resolution, I'll create decimals in between. You could score something at 4.5 if you like. But I like to start with 1 through 5 so that we don't end up in a lot of debate over if we have a 1 through 10, is something a 6 or a 7. I haven't found a lot of value in there, for a lot of general DFMEAs, unless, as we're creating these, we realize it's very likely we're going to be debating those points. But we want to do that process of figuring out what is the best type of table and what are the definitions that are most meaningful before preparation. So you can see here, for these different 3 categories of severity, detection, and occurrence. For severity, one is something that could be just aesthetic, right? A paint chip, that doesn't really affect, in this case, the high level mission of the product. Whereas 5 could be catastrophic, death or injury. And then creating, 3 elements in between those two. That can be a great way to create that table. Likelihood of occurrence. We really need to make sure that we are going to be doing this within structures that are meaningful. Is it parts, failures per 1,000 that matter? Is it failures per month that matters? What are the types of failures and the cadence that they occur, and then the denominator that they are going against that is meaningful. So look to see, how do you currently right now measure field failures? How do people talk about it in design reviews? And select that. Don't pick something that is going to seem foreign, because it's going to be really hard to be consistent. Likelihood of detection. Now, there's a couple ways you can look at detection, and the way sometimes it's the detection is, what's the likelihood in the design process you could detect that you're making a mistake in the design? What's the likelihood you could detect in the manufacturing process or other processes, and in a way you could take action? I find that the most valuable one is, what's the likelihood the failure can be detected before the final effect occurs, so in the customer's hands or whoever could potentially mitigate it. The reason why this I find is powerful is because it drives the best actions. Again, going back to that principle, we want to make sure that DFMEA drives actions. And so, an action that could be driven is a design change that actually lets somebody know that a failure could occur. This is why prognostics are so powerful, where the system monitors itself and provides feedback and actions that can be taken proactively. Remember that? Proactive versus reactive. Here it is again as an actual outcome of the DFMEA. So, it allows us to in that Kaizen principle of making constant improvement, I feel that type of detection does the most. So another big part of preparation is setting boundaries. We want to make sure that we are analyzing the elements of this that are most critical to us and where we want to take action. We don't want to find out later that some people are considering, other peripheral parts to be a part of this DFMEA. We need to talk about this in advance and establish it as a very clear parameter for the DFMEA. So setting boundaries is a really important part of preparation. The second tenet, team members. There are 2 aspects to this that are I feel critical. The first is the team size. We don't want one that's too big. We don't want one that's too small. I feel between 6 and 12 people is a really good size. When you get to less than 6, you're getting closer to just a conversation. It's kind of myopic per the skill sets of those people. When you get to over 12, it can turn into a committee where you can't make decisions and there is just too much dialogue going on, and it might even result in too little dialogue where just one or two people become dominant and the rest fall to the side. A second critical element is that you have a very diverse skill set. So you want to make sure that you have the core engineering disciplines, electrical, mechanical, software systems, but you also really should try to get some very different vantage points on how this design can fail. Maybe it's field service, maybe it's somebody in quality or in manufacturing. It could even be somebody who's just in the receiving end of units coming back from the field and doing initial diagnosis. It could be a lab technician. So really look to be creative and think about who sees this product and how it's failed in the past in very unusual and very unique vantage points. The third is the admin roles, and there's three key roles here. You have the facilitator, the scribe, and leadership support. And all three of these are very critical for a DFMEA to stay on track. So let's take a look at them individually. The facilitator, this is the conductor. This is the orchestra conductor who is ensuring that everybody is working in synchronicity towards the goal that's intended. Some of their objectives are to make sure that there is a brainstorming, free-flowing idea, general feel of these sessions, and that people are allowed to share their ideas openly. Remember, we're looking to the future. We're looking to brainstorm. We're looking at hypotheticals. So it can't become overly analytical in the sense of somebody just, sharing with everybody history, and you have one expert who's doing that. All groups are heard from. That means that we have to be careful that the conductor is ensuring that there's no dominant parties or dominant voices in the sessions. The conductor is also going to make sure that we don't get stuck. And there's a couple ways you can get stuck. One way you can get stuck is you have just two experts that are just debating with each other. And it might be a very meaningful discussion and a big part of having the DFMEA really get to some good root cause. But we don't want to drag everybody else through that if they can't contribute. What the conductor will do at that point, the facilitator, is they will ask them to take that offline and to continue that discussion just one-on-one outside and bring it back to the next session. They might actually call a meeting and they might actually want to invite other people to be a part of it. And of course, people in the DFMEA interested in being a part of it can as well. But what's important is we're not taking everybody else through this process of a deep analysis they can't necessarily contribute to. They'll be interested in the conclusion, but that can be brought to the next session. And the facilitator also is going to make sure the failure modes are scored objectively. So with the scoring methodology, really what's important is not the raw numbers, it's the comparative values between the different line items. At the end, you really could erase all the numbers once you've sorted the RPNs in descending order as far as getting the value out of it. So they want to make sure that we're being consistent, that something that is ranked with a severity of 3 compares well with something else that's ranked with a severity of 3 much later on. And some of that is going back and reevaluating earlier line items that we suspect could have been scored in a different way simply because we've evolved how we've looked at it. And of course, you're going to evolve how you look at this unit and its failures and scoring it. And so when you do sort by RPN number in the end, the facilitator should have us kind of scan the whole thing and see if we want to rescore some things with the way it all kind of shook out. And there's something that just very intuitively doesn't make sense to have, item X be very high risk over item Y, but that from your experience, Y should be higher than S. Something has happened with how we feel about it and our knowledge and how it has actually gotten ranked. So we want to go back and do that. The scribe. The scribe is critical. This is the individual that is driving the spreadsheet, making sure that we have clear notes, our actions, and that closed loop, function is happening. Are things being driven as actions, and are they coming back, and are they being followed through on? And is our worksheet actively reflecting the analysis we're doing? Does it look comprehensive? The worksheet is a great way to see if you are going through the whole system systematically. And the scribe is doing all of this. And the pitfall here is you don't want the facilitator to be doing this. They can't facilitate. You don't want other team members doing it. Then they can't be part of the analysis. It is a full-time role and should not be something that's added on to another role. Leadership support. DFMEAs can fall apart really quickly if that they get started and then leadership starts pulling people off the team for other tasks. And I've seen that many times. Leadership has to commit to this team is going to be given the bandwidth to work with in implementing this tool. And that has to be very clear in the beginning, which means we also have to clarify with leadership, do they see the value in this? Are they in clear understanding of what the ROI is? I mean, and that comes down to us as in the people who want to implement the tool, making the ROI very clear and having that be the foundation that then pushes back against the desire later to pull people out and have them be a part of other tools. Time management, the fourth one. This is huge, respecting everyone's time. One of the things that turns DFMEAs into really a weapon against you is having them become a huge time sink where people feel like it's just this endless pit that they're throwing time into over month after month after month. And it's pretty personal to feel like your time's not being respected and you're going to disengage very quickly. And it also is going to show to leadership and other people that there's not a good return on this. So we want to always keep that in mind. Are we being efficient with our time? Are we respecting everybody's time? Are there people who are just in there who have become disengaged and are on their phone and on their laptop? Why has that happened? They have the ability to have a very valuable contribution if you invited them on the team. What's happened? Why is the time not being used effectively? So we want to stay very focused on, are we using time effectively? Are we respecting everybody's time? And the fifth is active in the design process. We should see the DFMEA driving the use of other tools. Remember that risk guidance, it's about using the right tools at the right time. But also the DFMEA can be brought back out and reevaluated later in the program. It doesn't have to be used just once. You can be there for as long as we want in the program. And we also shouldn't force it to be continuous where it just becomes this consuming task in the background and there's periods where it's not adding a lot of value. It can be completed and then put aside and then brought back at a later date when we're at a different point in the program where we think it's going to add a lot of value. And we know it's adding value if it's active in the design process. Is it driving actions, and are those actions creating results that then are helping us really understand risk? So if we follow those 5 tenets, we will always have a very highly effective and perfect DFMEA that is a super valuable and essential tool in making highly robust products the first time. So that's what I wanted to share with you about what is in this handbook. All of these handbooks have been written to be 60 pages or less with some good cartoons in there. And the idea is that you could really give this book to just about anybody. You could give it to your leadership and they could read it, within an hour on a plane flight. It's not, my other books over there are thicker and have a lot of stuff in there, but that's not for everybody, right? That sometimes we just want to understand a very important tool, or we want to educate somebody on it, and share with them how this can be helpful. So all 4 of these handbooks are done in a manner that could be handed to somebody who's not associated with reliability, not even associated to product design, but it might peripheral be a part of helping them accomplish their goals. And each one of these books has worksheets and looks to get you going and implementing the tool as quickly as possible. So we can just open this to questions.